Well, welcome to Working with Data Scientists and Why I Left My Job. Well, the first thing I want to do today is introduce myself. My real name, so the name my mom gave me is Francesco. But, you know, in my company, everybody calls me Frango. So feel free to call me Frango if you like. I work with Python, as you probably do as well. And I've been working with Python for almost 8 years now, which is quite a long time, I have to say. And currently, I work as a machine learning engineer in a company called Prima. We have a delegation from Prima here. We're also sponsoring this conference. And we have a stand outside. I don't know if you've seen it, but if you want to come and talk to us. And if you're looking for a job, go to this website, and you'll find all the open positions that we have. We are an insurance company, but even though we are an insurance company, we really care about tech. And I have to say we have a very strong tech culture. So you'll feel welcome in Prima if you like to come. And we are hiring in Italy, Spain, and the UK. And Prima is also sponsoring my presence here, so thank you, Prima, again. It's also paying my salary, so thank you twice. All right, now, the big question. Did I really leave my job because of data scientists? Well, the title was kind of a clickbait title. And the answer is no. And actually, it's quite the opposite. I've been working alongside data scientists for about 3 years now, because 3 years ago, in Prima, we had a problem with data scientists. Well, you know, they weren't working, well, I mean, they were working well, but not so well from the perspective of a software engineer. So we thought, why don't we create teams made up of data scientists and also engineers? So we created cross-functional teams with data scientists and machine learning engineers. And I have to say, in hindsight, it worked really well. And now we have a bunch of machine learning engineers in Prima, and we also have several teams adopting this practice. And let me smile for the camera, hello. And what I was saying. And it worked really well, and I consider this presentation kind of the summary of what I learned in this experience, what I learned about data scientists. Surely I learned that they are very smart people, but sometimes, you know, they kind of do it wrong. And, and today I want to consider with you 3 practices that are very common in the world of software engineering: version control, testing, and in general, checking the quality of your code. And this is something that, you know, you can ask yourself, are data scientists doing any of this? And why aren't they? And, okay, we'll consider each and every one of these, and we'll ask ourselves the question. All right, so let's start with the first one. What is version control? Now, most of you probably know what version control is, but I just want to give you some perspective. So if you're working in a big team and you have many people working on the same code, you're going to have a lot of changes all over the place, right? So you want to be able to keep track of what is changing, who is changing something, and when the change is happening. And this will enable you to collaborate fairly easily, because you want to be able to review the changes, accept them or reject them. You want to be able to resolve conflicts. So if people modify the same code at the same time, or code that depend on other code, you'll be able to resolve this. And this, luckily, is a solved problem in software engineering. And the thing that everybody uses is Git. Virtually used by everyone. There are other systems, but no one knows about them. So you should be using Git. And when you use Git, you should be aware of its downsides, because, you know, every technology has its downsides. And I would say the downsides of Git are mainly 2. It can get kind of complex. If you have a huge code base, you have many people working, and you have a long history of changes. So you really have to know what you're doing. And there are some risks with Git. I'm sure each and every one of you have seen someone push credentials or secrets to Git. And, you know, that's very dangerous, and it happens to data scientists in particular. All right, now, the big question. Are data scientists doing version control? Well, I have a meme for you here that shows the way they generally do version control. And so we have a notebook, and, you know, the first one, the original one, is untitled.ipynb, and then you see this notebook being copied over and over again, and just the suffix changes. So you have the copy 1, Then you have the copy 1 final, but then you also have the copy 2. So it was not final after all, right? And so I think, of course, this is not a great way to do version control, because you're going to have versions being shared across people and sent over weird channels. Like, for example, I've seen data scientists share these versions through Google Drive, which, I mean, is not ideal. And so it's going to become a mess. Keeping track of the changes, keeping track of what happens is very hard. You're going to have duplicated code all over the place. So, you know, you should be using Git instead. All right, let's move on to the second one, testing. What is testing? I have to say I found this really nice and general definition on Wikipedia. And it says, software testing is the act of checking whether software satisfies expectations. So I really like it. It's very general. And of course, I mean, the bare minimum expectation you would require from your software is that it runs correctly and produces the right output given an input, right? And you can check that. You can check that with testing. In Python, we use generally PyTest or unit test or something like that. And ideally, you want to be able to assess if you make a change that shouldn't change the behavior of your code, you want to be able to quickly assess that your code didn't change. And so you want to be able to test frequently, automatically, and quickly. And again, as in the case of Git, there are some downsides here, because testing can get complex, right? Because you have additional code compared to the code that actually runs, and you're going to have to maintain that code, and that can be complex and costly sometimes. But still, people really like testing because it improves their confidence in their code, improves their confidence that their code is correct. And now, again, the question, are data scientists testing their notebooks? Well, I have another meme here for you. I'm not going to read it, but you can read it. And I don't know, if you were to take a notebook out of a data scientist code base and just try and run it, would that run? I don't know. Well, in my experience, on average, it doesn't. And there are a lot of reasons. For example, you might have dependencies problems. So you just run the first cell and pandas won't import. Or maybe the order of cells is weird because you are supposed generally to run a notebook from top to bottom, but you know very well that's not the case, because maybe you have to change a cell in order to make the notebook run. So in my experience, most of the time, notebooks are not reproducible. And of course, that is not great, right? Because we're doing data science, and so it's science. And I've learned at school that one of the cool things about science is that it should be reproducible. And often that's not the case in data science. All right, one last practice, code quality checks. This is something a bit different. So your code might be correct. So it might be producing the right output, but your code might be unmaintainable. So if making a change to your code is very costly and it's unfeasible, it means that your code is unmaintainable. So you should care also about non-functional requirements of your code. And we have two families of code quality checks we could do. The first one on the left is styling and formatting. So you want your code to look good. And why would you care about that? Because if your code looks good and has a consistent styling, people are going to be able to work on that easily, right? And luckily in Python, we have a formatting standard called PEP8, which stands for Python Enhancement Proposal 8. And we have a bunch of tools like Black, Autopip8, and Rough that will check the code and will tell you if the code adheres to that standard. And if it doesn't, you just run these same tools and they will fix the code for you. So it's very cheap, you can run it quickly, and it will fix the code for you. So why not adopt it? And on the right instead, we have linters. Now, this is a different family of tools. They will try to look at your code statically without running it and check if the code satisfies certain standards. For example, they check if you have unused code. So if you have a code that is not being used by anyone, why would you keep that code there? So they're going to tell you, you have an unused function, get rid of it. Or maybe you have duplicated code. So they will tell you, and you could extract that code into a function. So they will tell you a lot of interesting things about your code, and you're going to have to fix them manually. So it takes a little bit more effort compared to formatting, but it's still, I think it's still worth it. And now again, the same question as before, are data scientists doing any of this? Well, in my experience, sometimes they don't even know about this. I mean, they might know about formatting, but not about linting. And so I think they should. So if you agree with me, and if you think you're a data scientist, or you are a data scientist, and you are not doing any of this, and you think it might be worth looking into it, I want to give you a recipe, a series of steps to follow to make this happen, okay? So let's first start with the first step. And this might be obvious, but it's not. And it's to educate. So educate people, and if you need to be educated as well, educate yourself. And the reason you need education is often that data scientists come from a different background from software engineering. And of course, that's perfectly fine. I also come from a different background, and they are very smart. I am smart, and they are also very smart. And especially people coming from the sciences, they are very smart. But, you know, they come from different backgrounds, so it might be that they haven't been exposed to these practices. So they have to learn about it, and I think learning about it also uncovers the value of these tools. Because, you know, what happens in the world of software engineering, and we have to be fair because that happens, is that software engineers try to push things to people, right? Especially when they are best practices. But I think there's value in the practices we consider today. And if you learn about them, you'll see the value. So it means that data scientists and engineers are going to be on the same page, and that's what you want. Now, the second step, this is a little bit more technical. It would probably require its own presentation, but I wanted to mention it because I think it's very important. And it's the idea of moving away from notebooks. Now, if you really like notebooks, sorry, I don't like, I mean, okay, I have to say that they're nice. So notebooks are very nice. They're really shaping the world of machine learning and AI. But from the perspective of a software engineer, they kind of encourage bad practices. And I think the main reason is that a notebook is something that is supposed to be all in one place, right? So you have the code itself and also the output in this nice IPyNB file. I don't know if you ever looked into this file, but it's basically a JSON file with code and crazy outputs. And I think this encourages bad practices. In particular, it incentivizes you to have all the code in one place. So it's hard to extract code that should be reused across notebooks. So I think you should be oh yeah, there's also another point, sorry, I forgot about that. And the second point is the IPyNB file doesn't work really well with Python tooling. So the tools that we mentioned earlier, Black, Rough, and whatever, they all work on Python modules or Python packages, so they don't work as well with IPyNB files. So if you agree with me, if you think this makes sense, I think you should try and move away your code from notebooks and just keep the code that really needs to be in the notebook. And maybe you could package your code so you can reuse it across notebooks. All right, so if you agree with me, if you're educated, you're a data scientist, if you don't like notebooks, just like I don't like them, now it's time to adopt. And this is a critical phase, I have to say. And the critical part of it is to do it gradually. You know, in the world of software, we are always tempted to do what is called greenfield development. So if you're in front of a messy code base, and I don't know, you want to test it, well, you're going to be thinking, well, let's rewrite everything from scratch. But I suggest not doing that, because it's going to take you a long time to have working code. So instead, do a gradual adoption and move things out of the messy code base gradually, so you keep having working code. And in doing this, never forget the impact and effort analysis. So if there's a particular notebook that is critical and needs to be tested, so you're going to have to migrate that one first. And also remember that it's going to take you time and effort, so always consider this trade-off. And include the data scientists. So if you, like me, are a machine learning engineer in a team of data scientists, you have to include them in the planning phase and also in the adoption phase. Particularly in the adoption phase, you want them to help you. They've learned about this technology so they can practically help you and they can see the value of this technology. Now the step 4, which is, I think, probably one of the most important ones, is to make it fun. There are 2 ways I wanted to talk to you about. And the first one is memes. We've seen some memes during this presentation, and you also laughed, which is very kind of you. And I think the reason why you laugh when you see memes is because memes, you see yourself in memes, or you see someone else in those memes. So you recognize something in those memes that they make you laugh. So why not do memes about what you do at work? So if something fun happens at work, turn it into a meme. You're going to get a lot of karma, and also you're going to make people have fun. And work sometimes is very hard. So just let's make it fun. And the second tool I wanted to mention is gamification. So this is the idea of turning something that it's not a game into a game through the elements of rewards and milestones, the kind of things you would find in a game. And I've got a very nice example, I think, here. It comes from PyLint. I don't know if you ever run PyLint, but let's suppose that you run PyLint on your code base, and everything is fine, so your code doesn't have any problem. PyLint will print your code as being rated at 10 out of 10, which is pretty cool. Thank you, PyLint. And I see this as kind of a gamification element, because it gives you the little boost of confidence. Maybe you've been trying to fix the PyLint errors for an hour, and then you get this nice rating on your code, which is nice. And we expanded on this a bit, because we also added a beautiful thank you for linting ASCII art with different arts depending on the repo. Something very silly and something very cheap, but I mean, it's nice when you see it. And finally, the final step, don't leave your job. So don't give up. I know it can be messy, but really, when you take data, when you mix it with the intelligence of data scientists, and you also add the rigor and practices of software engineering, that's when the magic happens. That's when you really uncover the value of data. And that was it. Thank you very much. Now it's time for some Q&A. Oh, yeah, there are questions. Good, very good. Plenty of questions.
Thank you, Francesco. So, let's see.
Thank you. Yeah, because the first question was already answered by the slide on the notebooks. So, given that you abhor notebooks in production, I imagine that in Prima, as in many other companies, you use a platform that has to do with the bricks. So my question was, how much and how do you approach the fact that some part of the code will be strictly running on this platform, and how much of the code is external or agnostic in terms of execution, testing, and deployment? So thank you.
Very nice question. Yes, we do use something that ends with bricks in Prima. That's Databricks. And yeah, the situation that we have now is that we don't put notebooks into production. So no code that is a notebook goes to production. And we have dedicated repos and services where we put the output of notebooks. So data scientists are working on notebooks on Databricks, in our case. And the output of notebooks are generally artifacts. So models or anything that's relevant in machine learning. And then we encapsulate it in dedicated services, and we pay a lot of attention on the quality of the code that goes to production, so we keep them separated. I think it's not perfect because there's some separation that really doesn't make sense, because it's basically the same code, and I think it should be in one place, but it's not easy to make it work. And so at this point we are in this compromise phase. But I hope that we're going to push to the direction where we have everything in one place, and we have a one-to-one relation with, one repo for everything, basically. So notebooks corresponding to services. I think that's the way to go.
So many.
Okay, just a quick question. Among your team here, is there any of the data scientists that can confirm, or maybe we can hear the other parts of the story?
No, I can confirm that everything that Franco said is true. And now there is a lot of value in having both machine learning engineers, data engineers, and data scientists in the same team. It's a huge value. We went through a phase in which this was not the case in Prima, but then everything, as Franco said, exploded as soon as we embedded both engineers and data scientists in the same team. Yeah.
You know, data scientists always stealing questions. No, I'm joking.
Thank you. So, I see your hands.
Thank you. As a data scientist, I can confirm, I think. No, just two quick questions. You mentioned in your slide code review.
Yes.
I wanted to ask you how you do it and what issues have you found with it. And second, how do you force data scientists to use, I don't know, pre-commit hooks or something to force them to use linting and similar?
You just forced them? No. Well,
Except forcing them.
let's go with the first one. Code review. Well, we do it the way that generally people do it. We have a Git repo, and we have branches, and we require code to be reviewed before it gets merged into the main branch. So master, and well, the challenges that we found is that you have to repeat a lot of the times because, well, let me explain. So generally, well, initially, it was just machine learning engineers doing review to data scientists. But now these things is slowly changing because now data scientists have learned a lot and they're more comfortable, and we also don't want to be overworked as engineers. So we require data scientists to be able to do review themselves to each other and also to our code. And we require review, so we need at least one approval to merge into master. So that's kind of standard in the industry. And to answer the second question, how do we force them? Well, the way you force them is using continuous integration and pipelines. I don't know if something you've heard about, but when you work with Git and you use a platform like GitHub or GitLab, you can introduce some automation. Every time you push something to a branch, or every time you want to merge something into the main branch, there's some pipelines that are going to run, and they're going to check your code. For example, you could be checking that your code is correctly formatted. And if it's not, I'm sorry, you can't merge that PR. So we require that to be done. And then, of course, if you are trying to merge a PR, you're going to have to fix the code. So that's basically the way we do it.
Okay, thank you, Francesco. Sorry, another question for you.
Yes?
Yes, thank you. It's a really good presentation, first of all.
Thank you.
I'm guilty of being a data scientist, probably started with really bad practice. At the really beginning, but I agree with you. I think definitely move to a more standardized software development. Like frameworks is paid a lot. But there is, from my perspective, always a pain in this game, which is actually testing. So essentially, my question is about how you approach testing when you have to test a really expensive object like a model, an inference of a model that is not actually quite as easily predictable, easily built up like a normal software engineer testing. Thank you.
Oh, yeah, that's a very good question. Yes. Yeah, testing in the world of data science is particularly complex because what you're trying to do is first you want to kind of test notebooks, as we said. And there's one problem with notebooks, that they generally take a long time to run. So, and the main reason is that they ingest a lot of data. And what you want to try to achieve, at least this is what we do in Prima, is try to mock data. And the concept of mocking is something for which you try to, if you have in your test, if you have some expensive operation, you're going to try to fake it during the tests. And that's going to make your tests run quickly. And so we mock data. So we try, of course, it has to be a realistic data set, but a very small one. So we can mock it, and then we try to run notebooks from top to bottom and see if they produce the right output. As far as models are concerned, it's basically the same thing. Of course, a model is something complicated because it produces a distribution of outputs. So if you want to really test the model, you should be testing the distribution of the output. What we do is we test the model point-wise. So we always check that the output is what we expect on, I don't know, 5 to 10 points. So that gives us some confidence that the model is correct. And also, you always have to think about that a model is, in itself, is just like a function, but it is in a bigger context, right? And in our case, the context is pricing. So in the end, what we care about is that prices are correct. So we check on that, actually, instead of checking. Well, we also check the model in itself, but we care about the overall output of the thing. I hope that answers the question.
Yes, thank you. Thank you, Francesco. So, everybody, we are run out of time. So, if you have some other question, you can ask during the coffee break.
Yeah, I'm happy to socialize, as you can see here. So,
good,
come and talk
Francesco.
to me.
So, thank you, Francesco.
Thank you.